Okay, so we know from before that, say for example, the probability of A, well, what's the chances of A happening? Well, it's the number of successful outcomes of A over the total number of possible, or the number of total possible outcomes. Okay, so that's what we're used to dealing with in relation to probability when we're looking at just one event. And we know, obviously, like we did in our revision, that the probability range or the probability scale is between 0 and 1. Okay, so what happens if we're looking at two events, A and B, and we want to see can A and B, do they happen at the same time? Can they happen simultaneously or not? Okay, and that's basically what we're looking at when it comes to exclusivity. So the mutual exclusivity of events or the mutual non-exclusivity. So happen simultaneously or not. That's the question that we kind of keep in mind when we're doing these questions. So we'll look first at mutual exclusivity. Okay, so here I have a picture of two mutually exclusive events, and basically here's my event A and my event B, and they both happen but there's no overlap between them. So for example, the event A might be getting a heart, let's say, so getting a heart out of a deck of cards. Okay, and the event B might be getting a black card. Well, we know that they're definitely mutual exclusive because all hearts are red. Okay, so that's one example of mutual exclusive events. Okay, we'll look maybe now at non-mutually exclusive events. Okay, so here we have an example of two non-mutually exclusive events, A and B, happening, and we can see they're non-mutually exclusive because there's an overlap. So an example here might be where A is the event of getting a heart, like we said in the last example, but here B might be getting a king when pulling out the probability. So if we look further at this example, so there's the two examples. We see here it says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of both of them happening. So we've looked at that process before when we were working on sets at junior cycle, but just to remind ourselves why this might be the case. So we could have something like this example that we've said about hearts and kings. So here we can see we want to work out what's the probability here of getting a heart or a king. So this is this bit here. Here's our probability of hearts. We've all the hearts here and we have the king. Here's our probability of getting a kings, the four of them. And as you can see here, the king is double counted, and so that's why we have to reduce it. So we can see this even more clearly if we count up our cards. So say for example, we look here, the probability of heart or king is, well, we have 13 hearts plus our 3 kings, so that's 16 out of 52. Here, well, what's our probability of hearts? Well, we know there's 13 if we count all of those, so 13 out of 52. We can see here we have our 4 kings, so that's another 4 out of 52. And if I subtract the king that is a heart, the 1 out of 52, well, I can see that they're both equal. So it's just to remove, or to remember to remove, our double counting that we have minus the intersection of A and B, always in non-mutually exclusive events. Okay, so just finally then, so just to sum up what we've done there, in mutually exclusive events, the intersection of P, the probability of A and B, would be equal to 0 or the empty set. And so then probability of A or B is equal to the probability of A plus the probability of B. And so in non-mutually exclusive events, well, just as we've seen there a moment ago, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, the intersection. Okay, so those two definitions are both really important, and now we're just going to do an example or two including both of those. Okay, so make sure you get those written down. Okay, so here in this question we're told that X, Y and Z are three events. X and Y are mutually exclusive and we're told the probability of each of them. So well, the first thing we know, if two events are mutually exclusive, then the probability of X or Y is equal to the probability of X plus the probability of Y. So our answer very simply here is going to be 0.7, that's the probability of X we're told, and the probability of Y is 0.1. So the probability of X or Y happening is going to be 0.8. Okay, so that's our answer to the very first part. So this, we would have done that same kind of question in the past. Now here, explain why it is not possible for X and Z to be mutually exclusive. Well, say for example, if X and Z were mutually exclusive, we would have the probability of X union Z, and we'd say that's equal to the probability of X plus the probability of Z. And if we do that, that gives us 0.7 plus 0.6, which is equal to 1.3. And we know we can't have any probability that is bigger than 1, and that is greater than 1. So therefore, it's an impossibility. Okay, so that's our answer to part 2. Okay, and so one final example, we're given this Venn diagram here, and we're asked to write down the probability of E. Well, we can see straight away that the probability of E is going to be equal to 0.1 plus 0.2, which is 0.3. We have, we're asked the probability of F, and so that's 0.3 plus the bit in the intersection again, which is 0.2, and that gives us an answer of 0.5. The next bit we're asked is the intersection itself, so P of E intersect F, and that's the bit in the middle, so 0.2. And then part 4, we're asked the union, so P of E union F, or E or F, is equal to 0.1 plus 0.2 plus 0.3, which gives us an answer of 0.6. And then lastly, we're asked to verify that P of E union F, so E or F, is equal to P of E plus P of F minus P of E intersection F. Well, here we have E union F, we found was 0.6, and that's equal to 0.3 plus 0.5 minus 0.2. So let's add that together and see, do we get 0.6. So 0.6 is equal to, well, 0.8 minus 0.2, which is 0.6. So therefore we have that shown. Okay, so let's get these notes down into our copy and then check Schoology for questions.